good afternoon, students. Hi, how is everyone? I hope you can hear me. And to all those students out there, okay, I hope you've had a good Saturday. Okay, so we have not had any classes, Saturday classes for the past few weeks, I think. Okay, so but it's time to continue because I just want to finish it soon and we can I have a lot of time for revision, okay, when we go back to school later on. All right, okay, so first of all, can you please give me feedback on whether you are able to hear me loud and clear? Okay, good afternoon, Minyin. Okay, good afternoon. Can you hear me, Minyin? Please post in the comment here because sometimes my microphone may not be loud enough. Okay, if there's any problem, let me know. I can adjust the volume. Okay, Minyin, thank you for your feedback. Okay, with Jiawei. Yeah, okay, thanks. Good evening, Jiawei. All right, let me start today's lesson. Now, today's lesson, I've broken it up to two parts. So it's going to be part one. Okay, KE, good evening. Yes, second part will be next week when we enter our class for our usual class in the morning. All right, okay. So we will do first part here, so it won't be too heavy lah. So I do not want it to be too heavy for you. We just break up into two parts. Okay, today we're going to do 10.1 part 1. All right, so first of all right, so no problem. I will share screen now. All right. Okay, I hope you can see this. Right, environmental sustainability. So we're in chapter 10. That the other week, or rather this week, we have started chapter 10.4 because we wanted to do the project-based learning. So now we go back to 10.1. Okay, right, let's look at this. Now, here I'm going to look at some problems. What are the threats to our environment? Okay, so this is something that you already learned actually in in lower secondary. I'm sure you've heard of a lot of these things like global warming, okay, and then greenhouse gases, the greenhouse effect, and so on. So this is considered like a revision and also a little bit of extra facts for you lah. Okay, it's not difficult. So you just need to remember that these are all environmental issues that will come out in your essays. Mostly in your essay. Sometimes it can also come out in the, you can also have these questions in your structure and of course a little bit in the objective. Okay, but if it comes to essay, if you know your facts well, there are a lot you can write actually. Okay, so let's not skip this part. You try not to do away with this part because it's also important. Okay, now let's look at this 10.1, threats to the environment. So first of all, let's look at this term called environmental sustainability. Okay, so this is a term that every country now uses, all the organizations uses environmental sustainability. What does it mean to be able to sustain your environment? Okay, so environmental sustainability means environmental condition that remains the same without any reduction or depletion of natural resources. That means you do not want to make your environment become worse in the sense that it becomes the natural resources becoming less and less. You do not want your natural resources to deplete, means become less, or you do not want it to reduce. Okay, you want it to remain the same, and also you want to preserve the quality, okay, of the environment for a long period of time. So sustainability means a long period of time, not just for this year or next year. That means for eternity, so that it can go on for many, many years to come. That's called sustainability. Okay, so I will add in notes from here. So the number one here is basically the same thing. This is the definition according to the textbook, right? Environmental condition that remains the same without any reduction or depletion of natural resources, and also assured quality of the natural surrounding or natural environment for a long period of time. So you can look at the main key the facts here. So look at the facts here, you have remains the same, okay, without any reduction or depletion, and also must be able to sustain for a long period of time. Okay, long period of time. Okay, so that means what are we sustaining? We're sustaining the wildlife, water, earth resources. There are so many things we want to sustain. Resources, okay, water, the air, wildlife means animals and plants, okay? Also the renewable and non-renewable resources. Okay, so here what are the threats? The threat is all related to human activities. So we are the culprits actually. Okay, we have been poisoning our earth for many, many years. It's only recently, for the last 50 years, that we have already come to our senses, and we're trying to undo the damages that we've done for hundreds of years, in fact, thousands of years, okay, when we started. So what threats nowadays? So let's look at the 5 threats here. Your textbook is 5 actually, because this one is already pecahkan, this one is lumped together in your textbook. Okay, so number 1 is climate change. Climate change is very general, okay? Global warming is one of the thing under climate change. So climate thing is the general thing. Includes the change in temperature, includes the change in the rain distribution, and also includes the change in the wind patterns. So global warming is just about temperature, but climate change has to do with the temperature also, and the rainfall, and also the changes of the wind, and also the tide and all that. Okay, so it's climate change is a more general thing. Deforestation, that means cutting down of the trees and cutting down the forest, clearing the forest, that's called deforestation. Okay, and loss of biodiversity, so they are interrelated. When you have forests that are cleared, you will definitely have a lot of animals and plants that do not have a habitat to stay, because the forest is their natural habitat. Okay, so you will have loss of biodiversity. That means there will be certain species that will become extinct if we do not do anything to change that their condition. Okay, next one, eutrophication. Now this one may be something new to you, so that's why I'm going to explain this. Today I will touch on climate change, deforestation, and loss of biodiversity, and also eutrophication. So for the other second half, the second part, these two, right, pollution and human population growth expansion, I will do in the next lesson. So today I will just handle this one, right? This 4. All right. Okay. Now let's look at climate change and global warming. Okay, climate change, like I said, it's more general, not only talking about temperature. When you think about global warming is definitely only about temperature. So when you talk about climate change, it's referring to temperature, not only that, referring to the rainfall distribution, okay, because it has to do with the cloud formation and so on. So if the climate changes, your cloud formation will also not be usual, okay? Drastic changes of the wind, so the wind patterns, where the wind blows and so on. It will also affect the environment. And of course, that affects the animals and plants, okay? So changes of the wind. Now, these changes can be seen as a result of the greenhouse effect. So this is a term that you have to remember, greenhouse effect. Okay, now, greenhouse, why do we use this term called greenhouse? It's because of a concept that we have. We actually have greenhouse, okay? But of course, this concept started overseas, all right? In tropical countries, we don't need a greenhouse because it is whole year round, it's very hot. You don't need to maintain the temperature in order to plant something, a tropical plant. So yeah, okay, so nothing so far. So in this greenhouse, the temperature inside is constant. It can be controlled. Okay, usually in temperate countries are countries which have 4 seasons. You have first of all spring, and then you have summer, you have autumn, and you have winter. So there are certain months of the year which you cannot plant because it's too cold. Like for example, winter, a lot of plants will go into hibernation. They become dormant and so on. But if you have a greenhouse where the temperature is controlled and it's always warm inside there, you can plant during winter as well. Okay, so that is the concept of greenhouse. So why we use the concept of greenhouse is because it's hot. Inside the greenhouse, the temperature is controlled and the temperature is relatively warm, so that there are certain plants that you want to grow is able to grow inside, even though the outside is very cold. Okay, it can be winter, it can be autumn, where the temperature is too cold for the plants to bloom and so on, to grow. Okay, so these changes can be seen as a result of greenhouse effect. So now let's look at greenhouse effect. What causes greenhouse effect? I think you already learned it previously. You learned in your, it's across the curriculum. I'm sure you learned it in your PM, kesan rumah hijau. You also learn it in English. You learn in so many other fields, and maybe your physics or chemistry also as well, because it refers to the CFC and chlorofluorocarbon, the methane, and so on, and the nitrogen oxides and that. These are the gases which are called greenhouse gases. Okay, now, so what is the meaning of greenhouse effect? Greenhouse effect is caused by an increase in the level of carbon dioxide. So one of the main culprits, one of the bad guys, we call it culprits, that causes the greenhouse effect is because we have too much of this accumulation of carbon dioxide plus there are also other greenhouse gases. not only one type of greenhouse gases. So one of it is carbon dioxide. You also have methane. You also have CFC, and also the nitrogen oxides and dioxides. Okay, so what happens is when you have too much of these gases, it accumulates in our environment and it traps the heat. It traps the heat so that the heat is not able to be reflected into outer space. So that means the global temperature will rise as an effect, as the overall result. Okay, let's look at greenhouse effect. Okay, now as you know, right, we get our heat, our light from the sun. So we have a layer of atmosphere. Okay, let's say, let me color this green, this blue area. This is our atmosphere. All right, this is atmosphere. So the sun penetrates the earth through radiation. So this is one of the methods of heat transfer. When it comes from the sun, it has to do with, yes, it has to be transferred through radiation. It cannot be conduction, it can be convection, okay, because there's no particles involved. Radiation, in terms of heat transfer through radiation, it can happen through vacuum. Okay, so we have vacuum in between the space in outer space. Okay, so now when the heat or when the sunlight penetrates through our earth, to the atmosphere, so of course it goes through the atmosphere. Now some of it gets reflected back into space, okay, because of the heat from the ground, the earth. So it gets to be reflected back. So this is common, right? But the fact is, a lot of this infrared radiation, that means the heat, cannot go back into space because we have a lot of these gases which are called greenhouse gases. So one of those is carbon dioxide. So they actually trap, let's say this is a layer of carbon dioxide which is in our environment. So it traps the heat, it traps the infrared radiation from going back into space. So what happens is you get it reflected back to the earth. So here you will see that here the light, let me put pink color. Okay, this is here, right? It's supposed to go up, right? But it gets reflected back. So it does not escape the heat. A large part of the heat that's supposed to go back into space does not get to go back into space. So we have an accumulation of temperature, accumulation of heat near the Earth's surface. Right? This is because we have these greenhouse gases all over in our atmosphere. It traps the heat. Okay, so this is, you see the increase in the concentration of carbon dioxide over the years since 1960. Okay, right down to 2000 is a span of 40 years. Okay, so you find that the rate increases, it's going like this. So a lot of our human activities involves producing carbon dioxide, which is very, very bad for the environment. And you can see our global temperature, okay, 1995, of course this is old data, 1995. You will compare to 100 years ago, 1890. Okay, in 100 years time, this is the mean temperature. That means the average, okay. It went up to about almost like 0.5 degrees. Here is 0.3, here is 0.9, okay, about 0.6 degrees. Okay, Celsius, 0.6 degrees Celsius in about 100 years. Okay, it's going to keep on going unless we do something about it. Okay, so let's look at some explanation here, some description. Okay, energy from the sun reaches the earth through radiation. Okay, so some of this energy, this radiation is absorbed by the earth to warm surfaces of the sea and land. So the sea becomes warm, right, because it absorbs some of the heat. But of course, it cannot absorb all the heat. Okay, sometimes it reflected back into the atmosphere or into the outer space. Okay, it's supposed to be emitted back or released back into the space. But of course, this radiation is prevented from escaping because we have a lot of these greenhouse gases. Example, carbon dioxide. So you got to remember a few examples. Okay, let's look at, carbon dioxide. Remember the carbon dioxide, methane, nitrogen oxides. That means there are two types, nitrogen oxide and nitrogen dioxide. Nitrous oxide and nitrogen dioxide, NO and NO2. Okay, they are called, collectively, they are known as nitrogen oxides. CFC, chlorofluorocarbon, and also water vapor. Okay, so water vapor is not that bad, but it's all these gases are actually trapping a lot of heat. So particularly carbon dioxide, it absorbs the infrared radiation. As a result, the heat is radiated back to the Earth's surface and makes the Earth become warmer. Okay, so this is the same effect with farming. When you use a greenhouse, it traps the heat of the sun. So it keeps the air inside the greenhouse very warm so that you can plant even in winter. When the temperature drops outside, you are still able to maintain a certain temperature inside your greenhouse. Okay, so over the last how many years, right, temperature has increased 0.2 to 0.3. In about 100 years, increased almost 1 degree Celsius. Okay, so it is rising, steadily rising. So what are the activities which can cause the increase in concentration of carbon dioxide? What are the things that can release carbon dioxide? Okay, so basically remember a lot of burning, every activity of combustion, every combustion produces carbon dioxide. Okay, now why? I'm sure you learned in chemistry before. A lot of the materials that we use to burn, like paper, wood, anything used to burn, it has carbon. Carbon is one of the most abundant elements on our earth. So you have carbon inside the substance, whatever is you're burning. So when it gets burned, when anything burns, it combines with oxygen. See, oxygen O2. So when you combine carbon combines with oxygen, you are definitely going to get carbon dioxide. So as a result, whatever you burn, because the thing contains carbon, your carbon will combine with oxygen, okay, and you're going to get carbon dioxide. So that is inevitable. You cannot run away from producing carbon dioxide when you burn things. Okay, so the less you burn, the better your earth will become. All right, less carbon dioxide. Okay, so combustion of what? Anything. In fact, paper is also able to combust. Fossil fuel, okay, fossil fuel, you have a lot of carbon in fossil fuel, mainly coal, natural gas, petroleum, everything. Okay, petrol, diesel, all of them, they are called hydrocarbons. So you have a lot of carbon atoms inside your compound here. So, and that produces carbon dioxide. Okay, forest fires. Okay, whether deliberately you are having a forest fire because you want to clear the forest, it is cheaper, all right? Why do people have forest fires and they purposely burn the forest? Because it's cheaper than to bring the heavy machinery to cut down those big trees, okay? Because you want to clear the forest, you want to build something there. So it's sometimes, forest fires is actually human activity. Sometimes it could be natural because of the temperature is too high or too hot and it's too dry, it may just combust, just like Australian wildfires, they're called wildfires. Okay, but it also can be human activity. People deliberately burn the forest because they want to clear the forest. So forest fires or burning, this is deliberate burning of forest for agriculture. You want to clear the forest because you want to plant there. Deforestation, cutting down trees, because when you cut down trees, you are removing the plants, and then plants, the good thing is they absorb carbon dioxide. So when you don't have plants, will have more carbon dioxide because nothing absorbs carbon dioxide better than the plants, which need it to use to produce food during photosynthesis. So there's nothing to absorb the carbon dioxide or use the carbon dioxide. Okay, open burning, all right, this is like burning rubbish. It's also a bad thing. Okay, so we do not try to dispose of rubbish by burning it. Okay, let's look at the gases which are involved. Burning involves carbon dioxide, and also if the substance has nitrogen, you're going to produce nitrogen oxide. If the thing that you burn has nitrogen elements inside, you're going to get nitrogen oxide. Deforestation, of course, you will increase carbon dioxide because no plants. You cut down the plants, the carbon dioxide will increase. Animal farming, you have cows, you have this livestock, okay, and they have animals, they have in their intestines, they will have bacteria, they will produce a gas called methane. So in fact, also we have it in our body, our large intestines will have bacteria. We also produce methane, and this is the characteristic smell, the smelly smell that come out when we fart. That is the methane smell there. So that is a greenhouse gas. Okay, agricultural activities, nitrogen fertilizer, all right, you will get nitrogen oxide. Then usage of cooling substances or coolants when you produce your refrigeration or air refrigerator, and also this aircon, you get carbon, chlorofluorocarbon. Now we do not use CFC, we have a alternative which is called HCFC, hydrochlorofluorocarbon, which is a little bit better in the sense that it does not harm, it does not break down the ozone layer as much compared to your CFC. Okay, so methane. Methane is produced from the activities of bacteria. So bacteria thrives in our large intestines. So because of the reaction between the bacteria and the food that's inside your intestine, it produces methane. So you also get it at the mangrove swamp, okay, in under anaerobic conditions, because that bacteria lives in anaerobic conditions. The ones in your stomach as well, in your intestine also, because very little oxygen there. Okay, alimentary gut. Gut is your intestines. In your alimentary canal, your large intestines. The ruminants and animals which eat grass like cattle. Also decomposition of organic waste in landfills, and also leaks from gas pipes and coal mines. All this produces methane. And methane traps a lot of heat, over 21 times more heat than carbon dioxide. So it's even worse than carbon dioxide in terms of trapping heat. Okay, CFC is also bad because it is also heat absorbent. It is able to even trap more heat compared to the methane and your carbon dioxide. Okay, so these are, remember these three examples at least of the greenhouse gases. Okay, now effect of greenhouse, or call it greenhouse effect, global warming. So what are the effects? What happens? Why must we not let this happen? Because these are the things going to the result. First of all, you will find that the polar ice cap will melt. When the temperature rises, they'll have the melting of the polar ice cap. So these are glaciers and also the icebergs that are floating in the ocean, in the Arctic Ocean, and also in Antarctica, the North Pole and the South Pole. You have huge amounts of this ice. Okay, they will melt because the temperature rises, so they start to melt, and when they melt, they become water. So it flows into the ocean, and that causes an increase in the volume of water, ocean water. So that means the water level will rise, the sea level will rise. And this is a phenomenon that's actually happening. A lot of cities here are actually going underground, going underwater. Okay, like certain low-lying areas, countries like islands of Tuvalu in the ocean, Pacific Ocean, right? Bangladesh, and don't forget, very near to our neighbor. Do you know that Jakarta, right? Jakarta is actually sinking. It has been sinking for some years, and actually nowadays, a few years ago, the government of Indonesia has planned to relocate Jakarta, the capital of Indonesia, to another place. Okay, so they're planning to relocate to the island of Borneo. At the moment, Jakarta is in the island of Java. So they are going to relocate the Ibu Kota, the capital, to East Kalimantan, okay, which is in Borneo. It's very near to Sabah side, okay, because Sabah, Sarawak, Brunei, we share with Indonesia, okay, on the island of Borneo. So they are going to relocate Jakarta to, there's no longer going to be the capital city. A few years later, they're planning, so they're going to move to Borneo. Okay, so that's one of the reasons, actually, because it's actually sinking. Okay, climatic changes. So it speeds up when your temperature increases. It's going to speed up the rate of evaporation. So water will evaporate very fast. Okay, when water evaporates fast, that means they will have drying up of the inland. A lot of ponds will dry up, a lot of lakes and rivers. Okay, and you have more deserts. Okay, you have frequency of drought. Drought means musim kering. We call it kemarau. Okay, and also you have change in wind direction and sea currents. You also have natural disasters and so on. Okay, typhoons, hurricanes. So this is basically a change in the climate. Okay, so the first point is sea level rises. The next one basically is the climatic change in terms of the drought. The rainfall will change. And next one, agricultural productivity. Because you have lack of water, your crops and the livestock, crop means plants, livestock means animals. They will also, because of lack of water, it's just temperature increase. Activity of crops will also in temperate countries. Oh no lah. Okay, we're not talking about. Okay, of course, in temperate countries, you will have crop. The crop will increase when it's become warmer because but in countries like us, when we have whole year so hot, right? When you have the temperature increases, actually a lot of the water will evaporate. Then you're gonna have the dry season, musim kemarau. Animals will start to die. They can increase them. They will become extinct one day. So what are the solutions? So first thing of all, you need to reduce the emission of greenhouse gases. You need to reduce methane, CFC. Emission means release. Okay, reduce the release of this kind of gases. And at the same time, we need to develop cleaner fuels. Do not do not pollute the environment. Okay, and alternative energy resources, wind, okay, wave, using solar sets, all these they do not pollute the environment. They do not release anything that is undeniable that can harm the environment. You have to control the forest. Okay, make sure that people do not cut down trees without license. And even if you cut down, normally there is a rule that says that when you cut down, you have to plant it back. So every tree you cut, you should plant another new. And even then, that new tree take many years to grow back to the state of the old tree. Okay, the tree you can cut a matter of half one big tree, but grow back a tree to that tree, it takes at least 40 to 50 years to grow back. You see, so easy. Half an hour cut down one tree, you need 4 to grow back that tree. Okay, so now you see there's a depletion there. Okay, replanting trees. Okay, that is a good plan. You should replant trees as and then trees to absorb carbon dioxide. Okay, so deforestation. What happens when you have deforestation trees? Not only it removes your carbon dioxide, actually it is also bad for the soil. Okay, let's look at all the effect of deforestation. Cutting down trees in the forest for agricultural. You want to make a farm, right? You need to cut down. You need to cut down the forest to make trees. So what's the effect? Soil erosion. You have thinning of the soil layer because when there's no roots to the soil. The soil is easily eroded away when there is wind or where there is a heavy thunderstorm or when it rains. So there is no roots to hold the soil, okay, to hold the soil in place. And also the leaf, there's no leaf there to absorb impact. So when the rain, right, it hits the ground quite hard. And also can rush up the soil and the mineral also be diluted. Okay, these are cut. The surface is the soil is exposed, and also you get water or soil erosion. Then worse, you will also get landslide where the mountain collapses and fall of an earth because it's been for a long time. Okay, the water has seeped into the mountains, loosened all the soil and so on. So there's nothing to grip the soil. There are no roots to grip the soil, so it all crash down. So sweeping down accumulation of rainwater. Okay, after time, heavy few days, then you can feel the mountain can just collapse. Okay, flash flood. Now this is also after effect. Landslide, soil go. The soil can run the river. So when it runs into the water will be displaced. The water comes out the river, all right, and the water will actually become flood. You have flash floods when the drainage, okay, like in KL, we have a lot of this flash floods happens quite often because of the drainage. Okay, have this a lot of people throwing rubbish into the longkang is also not because it clogs the drainage system, and you will have when the rain comes immediately what we call a flash flood. Okay, banjir kilat. This is because of lands. Also, the eroded soil goes into the longkang, it goes into the gutter, it goes into the rivers. So it causes flash flood during rainy season. Okay, loss of biodiversity. Okay, again, we have repeated this already. When you have deforestation, you're actually cutting trees. The species could be last few surviving ones. You didn't know, you cut away everything, and then it doesn't. There's no other plants to replace it, and that's the last of the species. Okay, and because of trees is stay, birds can also become extinct because trees for make nests and so on. So habitats for animals and will be damaged when you have deforestation. Okay, and in the end you have extinction. Climate changes. Okay, there is less transpiration. Okay, that means water will not what do you call, you have less transpiration, filter resulting in fewer and lesser rainfall. So there's not much water going up into the atmosphere to form clouds, and then when you don't have waterfall. Okay, it's hotter and drier, and of course greenhouse effect. So it's all okay. So that's why this one is very open. There's a lot for you to write. you can goreng, and most of the time you will hit something. Okay, so for this kind of topics, I do encourage students to write. If you are not able to remember a lot of this hard facts, such as something very fixed, like all the cycle and all that, you cannot remember. You write all these issues marks because it's too wide. But if because this is very general and you will score something. Okay, of course you may not get the full marks, right? But better than doing nothing. Okay, so greenhouse effect. When you cut down trees, you actually increase more carbon dioxide because the trees actually reduce outside. Okay, so basically this is what you have heard, right? What I'm doing is just reinforcing the fact, making sure that you have more things to talk about. I'm sure every one of you, by the time now you're in Form 5, you're already been from Form 1 until now, even school, I'm sure you have a lot of these facts. Only thing that you need to know how to write it out. The effect, cause and the effect. Okay? The cause isn't. The effect is what comes after that. So all this will be the effect. Effect of deforestation. This is what's going to happen if you have deforestation. Okay? So think of it that way. Questions when it comes to environment, ask you the cause and effect. Kesan dan akibat. What causes this greenhouse effect? And explain of the effect. That's it. Okay, so you just put in as much as you can. Okay, now let's go on to this term called eutrophication. It may be new to you, right? But it's something to do with our environment. Okay, so I think your comments here. Okay, eutrophication. What is the meaning of eutrophication? Okay, now let's look at this term. Eutrophication as a result of abundant supply. That means a lot of what? A lot of fertilizer. Let's say the farmer use a lot of fertilizer. Okay, or sewage, where all this dirty water from the toilet and all that, right? You will have nutrients there. Again, the nutrients not for you to eat, but the nutrients also, these are the elements or these are the inorganic substances which are actually good for the plant. Okay, like nitrogen is needed, okay, in the nitrogen cycle, right? Nitrogen, phosphorus, okay, all these are important as elements of the plant to produce their substances in the plant, in the body, in their tissue, healthy growth. These can become fertilizers actually. Okay, so what happens when you have a lot of this runs into your lakes or your pond or your river? Now the pond becomes very rich. Rich in what? In minerals, rich in fertilizers. Okay, let's do. What is the definition of eutrophication? It is excessive richness. Excessive 是过量 richness, that means the nutrient in the lake. Now this is for body of water. It can be lake, it can be river, it can be a pond, it can also be a drain. It must be a water body, a body of water. Okay, due to what? Due to off from off means it runs off. That means it's like flows in, flow away from the land. Okay, usually from farms. You use fertilizer. Then not all the fertilizer is absorbed by the root because too much. Then some of it will go into the soil, and when the rain comes, it's going flow into the lake. Let's say a nearby lake, and that causes dense growth of plant. Makes the plant life grow, but that's in the water. Okay, let's look at this diagram now. So you can see that why is eutrophication good? Okay, it's not good because it is too much of nutrients enrichment in the water source. Okay, let's look at this one. Now let's say next one you need, when you see, you should know what I'm talking about. There is actually substance we always get fertilizer: nitrogen, phosphorus, and potassium. Okay, this is the symbol NPK. Whenever you buy the inorganic budget or the fertilizer, you will always have NPK because these are needed for plant healthy growth. Okay, now let's number one. If you use of chemical fertilizers contain NPK, excess use, that means too much, right? Plant cannot absorb all of it. You have calculated, you put too much of this chemical in. So what happens is, of course, the plant will absorb some of it, but the remaining, the extra, it will run off Okay, it will run into go into the soil. Okay, it is going to be absorbed into this soil here. Let's say got soil water lah. Okay, soil water will be there. And then when the rain comes, right? When the rain comes, this water sheet off. We call it off. This nutrient will be leached. We call it, the word is leach. Leach in the water supply. Goes into the nearby lake. Okay, run off or say leach into the. Okay, those number one, number two is done. Number three. Now, what happens when you have these nutrients, which is N, P, and K? N, P, and K go into the water supply. Now, water in the water algae. Okay, algae. Algae is a plant, right? Algae is plant. So when you have the EK in there, wow, that's very good news for the algae. So the algae will grow very, very well. Okay, because this nutrient absorbed by the algae. These are new algae. The nutrients are good food for algae. So the algae grow very well. Of course, there's sunlight, right? It's got the sunlight. Yes, so it's growing. So now what happens? It grow well that it becomes that it will cover the entire surface. See pictures whereby you have algae bloom. I think I previously showed you a picture with the algae bloom. Everything is all green on top. There's a lake there, but everything is green. It's so slimy or green. It's because of the algae. So we call this phenomenon where you have a lot of algae growing there on the lake algae bloom. Put the L there because it's adjective. Algae bloom. BLOOM. Bloom because it is so it covers. Now when it covers it, of course, algae doesn't care. It's good, isn't it? It can like because it's on top. What happens? Plants are growing inside the water. So you may have plants that are submerged. Okay, like your hydrilla and your carbomba, your utricularia, and all this. These are the plants which are submerged. Don't forget not all plants are on the top. You also have submerged plant base where you have roots there. When you have algae bloom, of the lake actually blocks out the sunlight. So the sunlight is not able to, okay, this is the sun, right? The sun, algae, no problem, algae, no problem. It gets the sunlight. But these submerged plants, they cannot get the sunlight. So when they cannot get the sunlight, what happens? They cannot produce, they cannot carry out an important process for their livelihood. They cannot carry out photosynthesis because the light doesn't go in. So no photosynthesis, they cannot produce oxygen. All right, they may be using up oxygen until the oxygen inside there will drop. It will deplete. It becomes less. So when it becomes less, your fish also has less oxygen. Everything is inside there fighting for the oxygen, and the oxygen level will drop. And in the end, you're going to find that this whole lake will be lack of oxygen. Okay, oxygen will be depleted. So there'll be no more oxygen inside there, and the plants will die. Animals will die. The fish, I see the fish already belly up already, belly up. So it's already dead. So now when it's there's another problem. Bacteria break, you have decomposition of this dead plant and these dead animals. And when that happens, it's methane. It produces, it will get decomposition. And also once they finish up all the bacteria, at first it's the bacteria that is the aerobic bacteria. So the bacteria will carry out all this decomposition. Now, when no more oxygen, then it comes, you have this group of called anaerobic bacteria. So they're going to further change this tissues or that into other substances like your hydrogen, your methane, all that. It's going to be very, very smelly. The whole lake becomes a dead lake because of what we have this called enrichment of the nutrients, enrichment of the soil, of the water by this nutrient. So this is called eutrophication. So in the end, what you're going to get is dead lake. Okay, a dead lake that is going to be smelly because there's no oxygen, but you have this anaerobic bacteria producing all these hydrogen dioxide, hydrogen sulfur, and also this this methane and so on. I have a question here. Can algae carry out photosynthesis to supply oxygen? Algae, you see, algae is on the surface, all right? Yes, but you see, when the algae is on the surface, it can produce oxygen, yes, but you see the oxygen will not go water. Okay, oxygen, you have algae, the amount of oxygen that actually goes into the water, because most of it is going to be here, oxygen. So it don't really get a lot of oxygen into it has to be dissolved. So when you have a surface of algae, okay, you have, of course, it carries out correct, but it's producing, it's releasing oxygen, and it's more for the environment. You do have, but of course, algae, all right, very it's very small, right? You don't get a lot, but you still have it lah. Yeah. So it's a good question. Yes, but you do not have it in the water itself, and that oxygen is not able to go into the water. Your fish and your little animals in the cannot get the oxygen. So in the end, it will die actually. When you got the sunlight, the plants and the inside the water going to suffer. Algae on the top surface, no problem. They, of course, they finish off the supply of the nutrients, of course, and there's no more the algae will suffer lah. But it's always on the top, okay? You on the surface. Okay, so you phenomenon known as eutrophication. So you have these points. So here you can just see I've already mentioned animation. Just here. So algae up the surface, prevent sunlight from reaching the plants. As the plants in the water will die. And first of all, is the aerobic bacteria. They will decompose, and then you further using more oxygen until one day the radiation level becomes so very low. It's going to make the aquatic organisms and a lot of things are decomposing. Okay, later on you will have this bacteria which will put hydrogen sulfide, all these smelly gases, and the whole lake is going to be dead. Okay, now when you this use of oxygen, they're using a lot of fast, right? In fact, the decomposition also uses oxygen. So everything inside that is using a lot of oxygen. This is called increasing the biochemical oxygen demand. Okay, BOD. So this is the last point to explain about the B. Talk about water supply. Talk about the oxygen inside there. You have to talk about the biochemical oxygen demand. Okay, what does it mean? BOD. All right, BOD. Here, biochemical demand is the amount of oxygen taken by the microorganisms, whether bacteria or algae. They use oxygen to decompose organic waste matter. So now, if inside the water there is a lot of it is a lot of bacteria. I'll give you an example. There's a lot of bacteria inside there. What happens is this bacteria will use the oxygen inside there. So if I have a supply of water, all right, and a lot of bacteria, of course, this is no good, isn't it? When I say a lot, it means it's a polluted water, correct? Okay, when the water is bacteria, supply of water, right? Not bacteria, the activity going. The bacteria has to respire. The bacteria has to eat, means it has to produce energy, to produce, it has to get nutrients. So how does it do that? It's metabolism. Down whatever substance there is there, it will carry out or decrease so on, using up oxygen. Okay, so these stand for the level or the amount of oxygen. When the BOD is high, let me give you an idea. When the BOD is high, that means inside there a lot of things are using it. Basically, it means there's bacteria there, a lot of decomposition. It basically means the water is dirty. Okay, so that's why BOD high. So let's look at number 2. A high BOD is that there are many organic substances equals microorganisms. Okay, when you see the word microorganism, it can be a good thing, right? You know that the water is no good. Okay, in the water with a high level. So look at this keyword. When you have high BOD, means high level of pollution. Okay, so they go together. So I want you to concept, very easy to concept. What is the meaning of BOD high? BOD high means inside there that supply water is going to be a lot of things that needs oxygen to use. I mean, oxygen is used very high. That means there's a lot of activity going on. It is breaking down substances, and job, it has to be the bacteria. It has to be the organism. Okay, so that means the higher the BOD value, the more polluted is the water. Okay, so BOD equals pollution. The BOD high, that means the water is polluted. Okay, and also it means the lower the concentration of dissolved oxygen. That means less oxygen. Okay, there is more BOD, when it's higher BOD, a lot of bacteria, a lot of organism. That means eating up the oxygen very fast. That means low. Okay. How do we test this? So I'm going to explain later on. There is a substance that we can add into the to indicate how much oxygen there is. So this substance is called methylene blue solution. Okay, we have it in the lab. Can do explain if time permit. Okay, the presence of oxygen in the sample water. Sorry, water. When there's oxygen, the color methylene blue will become blue. But there is no oxygen. When the oxygen is depleted, okay, become less and less and less, the color will fade. The blue color will become less blue until it becomes colorless. Okay, so the amount of oxygen will show the blueness or the how high the level of blueness. The more blue it is, that means the more oxygen it is. It becomes colorless, that means there's no more oxygen. Okay, so now that means it's very from blue to no color. Okay, what does that mean? What does that mean? When the color is blue now, when the color is blue means oxygen. Okay, no oxygen. It changes very fast. If next hour, now I see the next hour again, it turns colorless light blue. It shows that something is using the oxygen there, and it's using it very fast. Okay, that means the water is microorganism. So when it's changing rapidly, it becomes the water is high polluted. That means there's something inside there using a lot of oxygen, and the water sample is said to be having a high BOD level. Okay, so let's look at, I really simplify this so you can try to take a picture. Remember this. High BOD value is what? It means polluted. Okay, it also means it's a shorter time taken from blue to color. That means very fast, very rapid. Rapidly, it changes from blue to colorless. Okay, I write this up because a lot of students, they always cannot remember, they can't get the concept. Fast change color means dirty or not in the water. Cannot remember, cannot make the connect. So I want you to remember when it changes fast, that means oxygen is used up. So when oxygen is used up, that means it's not good. There is something oxygen. Usually it's this microorganism. Okay, let's look at the time taken methylene blue to decolorize. If it's short, that means rapid, very fast, change color from blue to colorless. That means oxygen level is low, oxygen very fast. And that also means BO level is high. BOD level is high means the demand, oxygen demand is high. Then something is using the oxygen very, very fast. Level of pollution is also high. So these two are equal. Okay, remember BOD high means pollution is high. So conclusion, the water is polluted. Okay, so you just remember one only. Then the other one is the reverse. So it's always the easier way. Okay, where the time taken is long, that means, let's say the water, first you start the experiment, you take, put water blue color, right? And then you find that every day you go check on it, the water is still blue one. When the water is still blue, that means there's a lot of oxygen inside there. There's nothing using up oxygen. So the oxygen level is high, the BOD level is low. Okay, nothing is using oxygen there. The level of pollution will be low, the water is not polluted. Okay, now try to get the connection. All right, okay, so if you come now, just take a picture and read it again later. Okay, now let's go back to, I want to explain an experiment. Okay, so this experiment, now, when you do the experiment, the methylene solution, you add onto the water sample, you add into the base, a syringe. You don't drop onto it. Because when you drop onto it, the methylene blue will come into contact with oxygen. Okay, is to be avoid being oxidized by atmospheric oxygen, just like your DCPIP. Remember last time when you were doing your vitamin C experiment? Okay, we always encourage your not with DCPIP, the orange juice in your syringe. You put it at the base, drop it, put it directly into your DCPIP, not to drop into your DCPIP, because your oxygen or your orange juice or whatever juice you're using, when you drop it into the air, I mean, it goes into the air, oxygen will be able to oxidize to oxidize your vitamin C. So you put directly into the water, okay, for this methylene blue. And also you should not shake the reagent bottle. So this is a precaution. When you do experiment, do not shake it, because when you shake it, you're going to add air inside there, and it's going to add more oxygen. Means it's not accurate. You want to determine how much oxygen is in the water. If you shake it, you're adding more oxygen into it, so it's not accurate anymore. Okay, now let's go to the experiment. I just want to go through this experiment very simply. So which water sample has the highest BOD? So you're given a few examples of BOD, water sample. So you're going to test by using methylene blue. So you're given methylene blue. Okay, so the manipulated variable, you have different water samples, a few, at least 4 or 5 types. Your responding variable, you want to check on the BOD level, see whether, or you can say time taken. You can also put like this: time taken for what? Time taken for methylene blue to be decolorized. This is also responding. Decolorized. Okay, it's very difficult to write. I'm writing vertically. It's very difficult. And constant variable, volume of water. Okay, the sample of water must be the same. Your drain water, your pipe or tap water, your longan water, whatever, must be same amount, because different amount of water will give you either you have different amount of oxygen. Okay, you cannot compare. So amount of methylene blue, the volume must be same for every sample, and also the concentration. Don't forget, the concentration must be the same for every sample that you're doing. Okay, so let's look at the experiment procedure. Right, you put the fixed amount of water sample into reagent bottles, each one, right, and label them properly. Get 5 water sample, I think 6 here. Then pour into separate reagent bottles until full. Label them. Use the syringe at 1 ml, that means a fixed amount, a fixed volume, and also fixed concentration, 0.1%. Methylene blue into each water sample, and you can see the syringe, it goes directly inside. Okay, do not drop it from the top there. So, and put all of them into each one, put them into a dark cupboard. Label them properly, put them in the dark cupboard. Now, why do you put them in the dark cupboard? Why not leave them in the open, where there is sunlight? Happens. Okay. So actually, it's because of you want to prevent algae from growing. Okay, because if you have light, okay, algae will grow. Okay, so it's going to affect, because when algae grows, it's going to take oxygen there. It's going to reduce further oxygen. So you do not want algae to grow. And also make sure the reagent bottles are not shaken. When you shake, you add in the oxygen that is up there, right, into the air there, the air pocket there. You go into the water. Okay, then you check the reagent bottles every 1 hour for the next 4 hours, or you can, if by the next 4 hours you find that it still doesn't decolorize, you can carry on until the next day. You can carry on 2 hourly, check on it 2 hourly, or you can check it hourly. Okay, until all of them become decolorized. Depending long, see how clean is your water. If your water is very clean, you'll practically find your this one will take about at least 1 or 2 days to decolorize. Okay, now record the time taken, how many hours. So look at the formula here. You can use this, or you don't need to use this also can. The rate of water pollution is 1 divided by time taken. So that means the longer the time taken, the lower the water pollution. The longer the time taken means that the color will not decolorize. That means it stays blue. When it stays blue, remember I mentioned just now, stays blue means there's a lot of oxygen. Just remember, blue means oxygen. When it stays blue for a longer time, it will be, that means the water has a lot of oxygen. Okay, so the pollution will be low. So time taken is longer, that means the rate of pollution will be lower. Okay, so it 1 over. Okay, let's look at, let me give you some values so you can do some simple calculation perhaps. So you have 6 samples here: tap, drain, river, pond, well water, well perigi, and distilled water. So here, number 1, the question here, this one you need to do is 1 over. Okay, the formula here is 1 over, so 1 over 15. You will find that here, for this figure here, the longest one will be distilled water, and this rate of pollution will be the lowest. So if you use your calculator, right, use your calculator, just do some simple calculation, sorry. 1 over 15, let's do a simple one. 1 over 4 is 0.25. Okay, so it's 1 over 15. Right, sorry. 1 over, no battery. Oh, sorry. No battery, habis. Okay, let me use my phone. Okay, I think you get the idea lah, huh? Okay, let me just check, huh? 1 divided by 15, you get 0.07. Okay, I'm keeping it to 2 decimal places because it's 0.66666, huh? Okay, then this one, 1 divided by 6, you get 0.17. Okay, 1 divided by 8, you get 0.13 because 1, 2, 3. 1, 2, 5, sorry. Then 1 divided by 12. This is arbitrary units. These units I just give only. Randomly I give 0.08. And for this one is 1 over 20 will be 0.05. You will find that now this one will be the lowest rate of pollution, water pollution. That means the lower the number, the cleaner it is. The cleaner the water is. Okay, so 0.05 is the lowest figure. The time is longest. You can see time is longest, your pollution will be the lowest. Okay, 0.05, that's distilled water. Distilled water is definitely like quite clean, right? Because it's been boiled, it's been purified, it's been, you have already filtered and everything. Tap water is also treated. So you also, these are the two which are the, I would assume to be cleaner or less polluted. The one that is most polluted will be the drain water, right? And river, perhaps depending on how dirty the water is, drain water, pond water, you have a lot of microorganisms, you have a lot of substances inside there that is probably decomposing there inside there. So you find that the rate will be higher, okay, the pollution. So here you can see even a BOD level here will be low, okay, it will be low. And the rest you can say moderate or you can say high. It's up to you lah. Okay, so number 1, I already explained here. Why must you put the syringe to reach the bottom part here? Because you do not want your methylene blue to be by the air, okay, but when you drop it inside. Okay, for the experiment, which one the water sample takes the fastest time depending on your experiment. Okay, compare the BOD levels of all 5 water, in fact 6 here. Oh, here this is actually, this is the what? This is 5 water, but this is actually the control. The distilled water serves as a control. Okay, so number 4, why is this experiment being repeated using distilled water? So the answer is already given to you. This is a control. The next one, what is the relationship between time taken for 0.1, the time taken, what is the relationship between time taken and the level of water pollution? So as I mentioned here, the time is longest. You can see the time is longest. The level of water pollution will be lowest. Okay, so time increases, time high, the pollution will be low. That means it stays blue for a longer time. Okay, always remember blue means oxygen. The longer it is blue means the oxygen is there. When oxygen is there, that means it's not polluted. When the oxygen is gone, when it becomes colorless, that means there's a lot of bacteria using up the oxygen. Okay, so this is accepted. So always refer back to your hypothesis first. Has it been confirmed correct? Drain water has a higher COD. This is your hypothesis. So, and then you have your results correlate to that. See, does the result correlate to that? Drain water, yeah, 0.25. If it proves it, that means your is accepted. Okay, this is accepted. Yes, accepted. Yes. And your conclusion, very simple. You write back your hypothesis as your conclusion. So your conclusion is drain water has the highest BOD level. Okay, so this is what you always do. Always compare your hypothesis. Has it been proven correct? If yes, proven correct, you accept it, yes. hypothesis accepted. Your conclusion, you just write back your correct hypothesis. Okay, so this is the lesson for today. Okay, you see, already take up 1 hour. That's why I pecah into, I will split it up to 2 lessons. Okay, any questions here? Any questions here? I hope you've understood what I wanted to tell you. So next time we will, the next lesson next week on Monday, I'll continue with pollution. And the other one is, what is it? And the other part, which is pollution. There are so many, human population growth explosion. Okay, these are also threats. So there are 5 threats. I already covered all 3. I've covered 3 and then 2 more. Okay, all right. So any questions, you can telegram me. All right. Those who are there who are able to, you can just put a comment in in the video here, and I'll get to you. And for the other girls, right, or in my class, I'll see you on Tuesday. Okay. Bye bye, girls. Have a good weekend. Enjoy. Thank you, Jiawei. Welcome. Thank you, everyone. Bye bye. Bye bye.